interpass temperature impacts the strength of the weld, it is important for welders to master the process of maintaining the temperature of the weld zone within a given range, also known as interpass temperature control. Interpass temperature control is affected by time between weld passes, the thickness of the base metal, and the heat-related characteristics of the metal. If welding is interrupted, the temperature of the weldment has to be brought back to the interpass temperature before the weld can continue. Otherwise, there could be cracking. Regaining the minimum interpass temperature is usually straightforward, since most welds that require interpass temperature control also require preheating, and both processes use the same equipment and techniques. Post-heating is heating of a weldment after welding has been completed. The same equipment and techniques are used for post-heating as preheating. Select the buttons to learn more about post-heating methods. The most commonly used post-heat treatment is stress relieving. Stress relieving is done below the lower transformation temperature, usually in the range of 1,050 degrees Fahrenheit to 1,200 degrees Fahrenheit. Stress relieving is done for the following reasons. It reduces residual stresses in weldments and casting caused by shrinkage. This is especially important with highly restrained joints. It improves resistance to corrosion and stress corrosion cracking. It improves dimensional stability during machining operations, and improves resistance to impact loading and low temperature failure. Annealing relieves more stress than stress relieving, but it results in a steel of lower strength and higher ductility. It is done at temperatures around 100 degrees Fahrenheit above the critical temperature and with a long holding period. The item is then slow-cooled in the furnace or by covering, wrapping, or burying. Annealing generally leaves the metal in its softest condition with good ductility. Normalizing is a post-heating process that usually results in higher strength and less ductility than annealing, but is done at similar temperatures and holding periods. Normalizing is different in that the cooling is done in still air outside the furnace, and the cooling rate is slightly faster. This removes strains and reduces grain size, so that the metal is not as soft and free of stresses as fully annealed metal. Tempering reduces the hardness and the brittleness of hardened steel. This increases strength and helps avoid breakage and failure. Tempering is done at temperatures much lower than those used for annealing, normalizing, or stress relieving.